Hi, everyone. Welcome to this session. My name is Mia. I'm one of the producers for ToolFest, and we're really excited for this session, a rookie playbook for machine learning beginners. Your host today is Favor Nerys, a student at the University of Maryland, College Park, studying computer science and mathematics. She's also minoring in Arabic and global engineering leadership. And she's also currently building her first STEM-focused school in Cameroon. So I hope we get to hear more about that. Before we get started, I'd like to thank our sponsors for their support of ToolFest and today's session. And since today's session is hosted on Zoom, please take a minute to note where the chat is. Feel free to send any questions throughout the session there. And if you're watching on YouTube, we'll be monitoring the chat there as well. So send us questions or comments there. And I'll turn it over to Favor.
Okay. Hi, everyone. I'm Favor. Thank you so much, Mia, for the introduction. I'm just going to go ahead and share my screen so we can get started. Okay. Okay. So thank you, everyone, for attending this workshop. I'm pretty excited to do this. Oh, wait, sorry. I think I exited presentation mode. There you go. Okay, nice. So really excited to be a part of this workshop. And yeah, if you have any questions throughout the presentation, feel free to just ask in the chat or ask at any point during, and I'll come back to it. As Mia shared, computer engineering mathematics, a major at UMD College Park. I'm also the Region 2 chairperson of NSBE, that's the National Society of Black Engineers. Shout out to any NSBE members that are part of this session. Thank you for coming. My machine learning experience, I've done it in both research and industry so far as an undergraduate. Novelty detection, field crop yield, hurricane trajectory forecasting, filtering unusable data, and neural engineering. And my focus, which I hope to discuss with you all later today, is on scientific novelty and particularly for social good as well. A quick outline of what we're going to talk about today. First, we're going to learn about some machine learning concepts. So the entire goal of this session is to empower you to leave it feeling like you understand a lot more about ML than you do at the beginning. Just knowing some keywords, terms, phrases, debunking any misused information about machine learning so that you're able to best communicate it to others and also search for challenges yourself and be able to apply that in some way, shape, or form. Sorry, next slide. Okay, so first we're going to talk about what is machine learning and why do we learn. Also, this is going to be very interactive. So at any point, I might ask for anyone to share what their thoughts are. Please feel free to unmute yourself or add in the chat what you think. So does anyone have an answer for what is machine learning and why do we choose to learn? Okay, if no thoughts, that's why we have this workshop. Okay, so first up, learning. Why do we choose to learn? We choose to learn because data is cheap and abundant. Knowledge is expensive and scarce. So a lot of you might be very familiar with just the concepts of the hierarchy of information. So going from the rawness of information at data to building up to knowledge and all the way up to even wisdom. So data in its raw format, there's an abundance of it. Here, hence why you always hear the term big data when you're studying data science or learning about machine learning. And so the really key part is how do we sort of translate that information into something that we can better interpret as humans, or for a system to be able to solve some solution from just the raw numbers, figures, symbols, etc. So some applications of why we learn are when we lack expertise. For example, navigating Mars. We currently don't know what's on Mars. Trying to find signs of life on Mars, for example. That's one of the projects I recently worked on with JPL. So that's a particularly key part of why we use ML. Also, when we lack explanations. So for example, speech recognition, we have the ability to speak in many different languages, dialects, accents, and the likes. There's so many different components to it. However, it's very difficult to explain to perhaps a machine or a layperson with different experiences why we speak the way we do and what each specific aspect of it means. So we use things like machine learning to better enable sentiment analysis, for example, to understand the moods, the feelings behind what we say. Also, we use machine learning to explain changes over time. So for example, the computer architecture has changed drastically over time, from being very sort of clunky, big systems to now microchips that you're able to enable on practically almost any device nowadays. So things like that are really important to explain. And also to adapt. So for example, user biometrics are pretty important. You now have, most of you, I think, might have Face ID components or finger scans on your laptops. I do on this MacBook, actually. So that's a pretty interesting way to just apply things like AI and machine learning to enable society to better adapt as technology continues to grow. And so now we go into specifically more about machine learning concepts. So the entire objective for machine learning is to optimize task performance. How it does this, it uses algorithms and it applies it to data. So when you have data, you want to use that to train, and then you want to answer some question, right? It could be anything that you want. And the relation between this is that data is used to train whatever model you have, and then it predicts some variable output or tells you some explanation of the structure or model overall. The different facets of machine learning, specifically are statistics and computer science. I think nowadays there's a lot more focus on just building up the algorithms, but truly the foundation of machine learning is rooted in statistics. My fellow math majors, if you're on here, then you might understand a lot more about prob and stats and how this applies. So statistics enables us to make inference from a sample. So when you're able to feed in this big data that I talked about, this raw information that you want some knowledge from, you really use statistics to be able to define how you want to interpret it, how you want to draw conclusions from that data. So that's really important to have a foundation in as well. And of course, in computer science, that's really where you get to code, right? So you get to build out these algorithms that solve, represent, and evaluate the model. And also importantly, visualize the model, because at the end of the day, you have to be able to explain what you're doing to somebody else or to some other system, organization, and the likes. And this is a quote from Haldom III, who's at UMD. Machine learning is about predicting the future based on the past. So the past includes that data, it can be experiences, it can be a previous context in your data, etc. Now, the different types of machine learning, there are three main types. There are a lot more, but these are the three main grouped types, if you will, the main clusters. So the first is supervised learning, the second is unsupervised learning, and the third is reinforcement learning. Does anyone know any examples of each of these various groups of machine learning and would like to share? Feel free to unmute or drop it in the chat. Okay, if no one has any answers, we're going to learn about them. So first up is supervised learning. Supervised learning can be broken into two types of supervised learning. So the first is classification. And the entire goal with supervised learning, or the entire approach to it, is that you label the data. So think about if you have an inbox of emails, right? The entire goal of supervised learning is it says, give me a previous understanding of what this data is. So you would label your data as this being a primary email, this being an updates email, this being a spam email, this being a trash email, etc. Whatever context you're feeding into this model, it has an existing label. And then specifically for classification, you're predicting a discrete output. So it's very much almost binary in a sense, if you will. So it's this, right? Each of those are separated. Specifically, what discrete is that it's countable within a range. So for example, the number of attendees on this session, that's a discrete output, right? That just ends at a certain amount. There is no sort of increase in between the range of 15 people being on this call. Also answering good or bad, yes or no. These are also discrete outputs. And so an example of this is when you have a database of apples and cupcakes, and now you've labeled them as apples and cupcakes, and you feed it into this machine learning model. If you apply supervised learning and classification, then and you apply this test, you say, hey, I'm giving it a cupcake. It hasn't seen this model hasn't seen this before. Tell me what it is. The model then is going to give you that singular discrete output of this is a cupcake. So that's a quick example. The next example of supervised learning, regression, is that you're similarly given labeled examples like yes or no, good, bad, etc. But it's actually continuous. So take back the good or no, yes or bad. Basically, what this means is that you assume any value within a range. So for example, the amount of time elapsed so far that I've been speaking is 9 minutes and 38 seconds, or the weight of something or someone, or rainfall in inches or centimeters. This basically is very important to know the differences between this, because when you use a classification algorithm, you're sort of focusing on categories of prediction as opposed to regression, where it sort of gives you that wider spectrum of something to predict. So for example, regression focuses on things like the temperature, weather. What is the temperature going to be tomorrow? It says it's 84, that's its prediction. But it's important to note that between 83 and 84, there is practically an infinite amount of values that could be predicted, right? So you could say it's 83 point whatever degrees, and that in its own is infinite. So that's why this is specifically continuous. Then we move on to unsupervised learning, which is similar to supervised learning, but has a key difference. It has no labeled examples. So remember I said in supervised learning, when the data comes in, you're gonna label it as this is an apple, this is a cupcake, then I'm gonna give you a random thing, tell me which of these classes it is. In unsupervised, you don't give it that context. You just feed in this data and you say, I want you to better understand the relationship between these data entities, or I want you to find some association between them and help me better understand the data. So in unsupervised learning, you're not really searching for that discrete or regression output. You don't want that specific numerical number or yes or no, good or bad. You really just want to understand what are the associations in this data. So applications for this are in anomaly detection, when you're trying to find if something is adversarial to your model or database or whatever the use case is, if there's some noise introduced. Also for DNA patterns, this is really key in genetics and applying unsupervised learning, because it's very difficult to go and individually label every sort of genetic information that you might have. So you sort of feed in this genetic code and you try to find patterns in it to identify any sort of conclusions that bioinformatics might be seeking. And a popular classical example for this is also in customer segmentation. So trying to understand the differences and associations between customer behavior. And now an example of unsupervised learning, clustering, and dimensionality reduction is when you feed in this input data of apples, bananas, and peaches. You feed it into this model, and then your model basically groups them into 3 distinct clusters. That's what this does. Also to note, for clustering, it really focuses on forming groups, and dimensionality reduction here really focuses on compressing your data to have less features, but still maintain the same amount of integrity or explainability of your data. We move on to the next types of unsupervised learning. These are summarization and association analysis. So recall, I really just mentioned that unsupervised learning really focuses on finding out relationships in the data. So this is what this side of unsupervised learning does. You group these similar instances to either extract essential information. So an example of this is for text mining. Imagine that you're reading a huge encyclopedia report and you just want to understand, give me a summary, the Spark Notes version, the Cliff Notes version. You could create this model that you feed in this huge encyclopedia data set. And what it's going to do is it's going to extract only what's essential or deemed essential from the data to summarize it to you in some way, shape, or form. So you can imagine this will be very, very useful for context where you just have that so much text and you really want to be able to just compress that down to some way. Also, for association analysis, it focuses on finding relationships between entities. So what is the probability of something given something else? A popular example of this is the market basket analysis. So imagine you go to the shop, right? And you have your habits as a shopper. Say you always get bread, milk, or whatever X items. And what this does is it's really trying to predict what else are you going to need to add into your basket given whatever else is previously in there. So what's the probability that if you've bought milk, you're going to get bread? Maybe it's a 70% chance because it has previous context of you getting bread and milk associated together. So this is a pretty cool example of just how to use machine learning to a real life application. The next type of machine learning is reinforcement learning. So this really focuses on if you're given a sequence of states and rewards. So if you're given some acting agent in some environment, you're giving a series of just things occurring. And it tells you every time this agent selects this action, here's the reward. It's either small, it's medium, it's big, whatever range. Your goal through reinforcement learning is to predict what is the next best action to take at each individual step so that you can have the biggest reward. This is really key and has been very useful in policy and decision making. So what actions should an agent take and how good is an entire state? That's for utility analysis there. A popular example is if you imagine a puppy or a dog and you're a trainer, dog owner, trying to train your dog to have some behavior like fetching the stick or fetching the bone or retrieving a toy. So the dog is going to perform certain actions like running to pick it up and then bringing that back to the trainer or owner. And then the rewards are maybe every time your puppy brings it back, you feed it a bone or you exclaim in some way that makes your puppy excited. And we sort of note throughout the reinforcement learning example or through the model overall, what are the observations that we're making here? So maybe the puppy returns it, you get this reward. If it doesn't, then it gets no reward. If it returns it too slow, it gets little reward. The reinforcement model learns this continuously to make sure that finally, the puppy would always return the bone or stick in the best time possible to get that reward. And so before I go on to the next slide, which is going to be our group activity, does anyone have any questions on any of the concepts I've covered so far? Oh, I see the chat I was not seeing before. Oh, yes, Miguel, thank you for your contribution. Unsupervised learning, clustering, that is correct. Does anyone have any questions about supervised learning, unsupervised learning, reinforcement learning?
Is it possible with machine learning to only use one method? I mean, not just one method, but like, could you use a combination of the three types of learning that you described?
Yes, you can. Yes, you can. So there's actually things called ensemble methods or approaches. There are some popular existence of these like XGB Boost, or you can even create one. One of my projects, I had to create a custom ensemble method combining all of our novelty detection algorithms, and it put together dimensionality reduction. It put together decision tree making through random forest. So yeah, you can definitely combine different types of approaches to create this sort of meta model, if you will. It's up to you what the use cases are. In my case, all of them were required to better optimize the model because we had a lot of data, we had way too many features. We wanted to compress that. So dimensionality reduction made sense. And then we also wanted to be able to somehow cluster associations. And so we went through some unsupervised learning methods as well. Any other questions? Okay, we're gonna proceed to our group activity. And this is gonna take about 15 minutes. So feel free to try this out. And then we're gonna come back, and my most exciting aspect is when we have our dialogue about applying machine learning to social good. So I'm really excited for that coming up. And so now we have this group activity. If you could select what your level of experience in machine learning is and complete at least 2 lessons within your assigned range. These lessons take no more than 5 minutes. So even though it says it's a lesson, I promise you it's not long at all. I just want you all to be able to see what using machine learning feels like and have some experience with it by the end of this, and to go through a data set and all that good stuff. So yeah, select your level of experience and try to complete at least 2 lessons within those lesson ranges. And the link to the activity is listed on the slide. So bit.ly. Let me put it in the chat as well for those who need it. And we're going to come back in 15 minutes, and you all get to share if you had any difficulties, any successes, what you learned, and all of that by going through these lessons. Okay. Oh, perfect. Thank you, Mari. And I will, of course, still be here. So if you have any questions while you're going through any of the lessons, feel free to ask. Okay. We have about 9 minutes left for the activity, so I hope everyone's doing well with it. Feel free to ask any questions as you go through the activity or any of the lessons. We have about 5 minutes left for the activity, so please start to wrap up on your last lesson and get ready to share what you were able to work through. All right, let's take about 30 seconds to come back. Okay. So now I'm going to definitely seek input from you all because I can't possibly know what you all were working through. So could anyone volunteer to share what lessons you were able to do, any challenges, successes that you faced while running through them?
I worked on the first two lessons. They were pretty easy to understand, which was great because I'm a complete newbie to this. Um, it was definitely really helpful. I did like the part about the decision trees. Those are like really, they made it really easy to understand how the modeling operates. So
Nice. Thank you, Anu. Anyone else want to share what they worked on? Okay. In that case, we move on to our next part. Okay, so now we're gonna have an open dialogue. So for everyone who, so for everyone who has not been able to share so far, please get ready to unmute your mics because we're gonna need to talk and share together about various concepts of social good. So I hope everyone is excited as I am to have this part. So, oh no, I think one of the images got like cross-put altogether when I shared. But social good, we're going to be talking about what is the impact of machine learning in today's and future society, and more specifically, sort of how do we solve challenges that affect the social sector? So when we think about typical machine learning algorithms and applications, they're very much specific to the tech or scientific communities. So there's a larger disconnect between applying machine learning and AI to sort of the relevant, bigger global or community challenges that we face. And so this concept of AI for social good or ML for social good becomes really important when we want to solve problems that are critical to others of interest. And also when we want to be able to sort of garner different types of perspectives to form solutions that affect various regions, and that the ML solution effectively addresses the differences with some outcome. And of course, the tie of this social good application is for using ML in the solution. And at the bottom, sort of in little, I listed some initiatives and organizations that are heavily, heavily involved in the AI for social good movement, such as the Base Impact Data Kind. You might have heard of AI for All. There's a conference for that as well. Tech for Good Global is an amazing one. Comic Relief, and so much more. So feel free to become a part of those initiatives. There are hackathons, there are meetups, there are online groups, Slack channels, and orgs that you can join. So feel free to get involved with making sure that you can sort of create solutions that affect international change. And so now into the dialogue portion, I'd like to bring these concepts up to us and to really hear everyone's feedback on sort of how you are motivated to apply ML. What is sort of your driving desire to learn more about machine learning, and how can you apply it in a way that goes bigger than just, say, solving a project or completing a work task? Some examples of challenges previously concluded or currently in work or at work are forecasting natural disasters. This is something that I've previously worked on with hurricane forecasting. There's also ones for floods. And also if you live on the West Coast, there's ones now for wildfire, land suppression. So those are really important challenges that you can apply AI and machine learning to. Another one is in helping people with atypical speech. So I mentioned before speech recognition being a very good example of how and why we choose to use machine learning. So how do you sort of help those with atypical speech? Also relieving symptoms of brain pathologies. This is very common in neurotechnology and neural engineering, where you apply machine learning in some way, shape, or form to better understand and observe conclusions that are able to tell you more about the brain waves recording and helps you regulate some sort of threshold or signal within the brain to relieve these symptoms. And lastly, of course, augmenting individualized learning. So AI for social good has a big movement within education. So how can you sort of affect today's classroom and better create tomorrow's classroom with individualized learning or project-based learning? How does AI and ML fit into that? Some resources for these are the UN, United Nations Sustainable Development Goals. They have 27 challenges that you can sort of look at and decide, you know, which ones am I passionate about and how can I create a challenge or solution for them. And also Google has an AI for Impact challenge going on, which recruits nonprofits and various organizations to submit sort of solutions to these bigger problems. And so now it's your turn. I would like to hear from you all. What are some interesting challenges that you just think machine learning could be applied to that maybe they're not doing now? And specifically, I want to make sure this is for social good. So how does this benefit a community or social sector? Feel free to unmute and share or type in the chat. Miguel, did you want to share something?
Hi, yes, I just want to say I still don't know in which area I would like to apply machine learning exactly, but I think this link that this resource, UN Sustainable Development Goals, for sure there I will find an interesting project because I did a master in environmental engineer and I would like to apply machine learning for one of these topics like how to use energy in more efficient ways, or also how to better understand biological processes. Or I know there are many examples with DNA. They are not exactly AI for social good examples, but I would like to apply AI in these fields. I'm still learning, and I will have a look on this link that you share. Thank you.
Thank you. Okay, I see in the chat suggestions on analyzing video of body movement to prevent sports injuries, MRI, spinal cord injury prediction. Nice, those are some great ones. Love those. Anyone else want to share any ideas? Or if you have any questions that you want to bring up, that's what this dialogue is for. I want us to be able to really just discuss also the concepts just surrounding social good, like ethics, privacy, surveillance of AI and machine learning, and what are some ways that we can develop either policies or more algorithms in a way to regulate those, right? Because that's the future. So we need to start thinking about how to regulate and ensure the security and integrity of these systems before we get there. Oh, nice. Imari suggestion from Honest Expression on YouTube, hiring and recruitment. Well, that's a great one. HR is a huge sector in AI for social good, especially in topics like mitigating bias when hiring and onboarding, dealing with diversity, equity, inclusion. So yeah, great one there. Elizabeth, diagnosing skin tumors. Oh, that's very good. Nice. Love that. That would be very complicated too. So yeah, I love sort of the breadth and depth of these suggestions. I can imagine how complex some might get. Does anyone have any questions regarding using ML for social good, or just any policies that currently exist or the lack thereof, right? If you think about pretty much almost everything that we use now, there is some law policy in effect to regulate it. But there has been a huge discussion in the tech community because there is not much regulation for how we apply ML. So things like privacy, really not considered. So your data that you're using out there, just as a user of websites and applications, is being shared consistently. And so when we start thinking about applying ML to things like bioinformatics, things that require input of some person, human, or just private information, how do we start to ensure now that researchers or scientists or data scientists or yourselves, engineers and the likes, are just not putting information at the risk of having no privacy later on, or that it's being misinformed in some way? Oh, good question, Anu. When using machine learning to counter against bias in AI, couldn't bias also exist within the models or algorithms? You know what's funny? That was one of my questions, actually. So I previously had a slide with some guiding questions, but I wanted to leave it open. And it was discussing about the concept of when we think about fixing something, right? Sort of the chicken or the egg kind of situation. Do we go back to the root, which is we're fixing the initial algorithms, theories, proofs, and concepts, or do we just want to fix the applications of the algorithms? So that's a really interesting question. I do not have the answer. I am by no means such an expert to know the answer to that question, but I would think that bias still exists in initial algorithms because you have to think about the context of how the algorithms were developed in the first place. And if they were formed sort of in such scientific, say, narrow perspectives at the point in time, either because of when it occurred, the initial use cases, that might not be as relevant today or as inclusive today to other types of applications and solutions and people. So I would think so.
Hey, is my microphone on?
Yes, it is. I can hear you, Brian.
Hey, so I was thinking about the medical applications, and actually maybe it's a bit higher level, thinking about how the information actually gets into the model. So, like for example, capturing members of the population that aren't represented, or like getting, if it's about medical data, like collecting data earlier when people like to predict, you have to get people before they actually become injured or develop the disease. So that's been interesting, like this study in the UK that for the coronavirus symptoms, where they've just been asking people to log in and give their symptoms even if they don't have any, like if they're feeling well, and sort of tracking people over time and seeing if they develop something. So just the ways of inputting the data, like maybe I'm thinking about the difficulty in capturing information if it's not coming through your device or video watching you all the time. Like there's sort of trouble between like Big Brother and being watched and kind of always under surveillance, versus like, so the privacy issue of that versus like it's really valuable to have the data. So one way or another, like there's kind of a conflict. So I'm just interested, like, and then one other thing I was thinking about was in terms of with a medical system, if the patient has data, like the patient owning the data and moving between different systems rather than the system sharing between different stakeholders without the patient being involved. So the patient actually being the owner of their, I don't know if it's a kind of a like a model for social media as well, like you as an individual own your data and then you decide which organizations to share it between, but you always have all of it, so you can, like if someone needs it, you can give it to them and they can request it from you, but you always have like control of that. I don't know how that's being done, but maybe if anyone has any like suggestions.
Nice. Those are some great thoughts. Does anyone have any comments regarding those? Yeah, I think those were pretty interesting. The Big Brother example, I was actually watching Big Brother last night. So that was pretty interesting to hear about just that entire concept. And even when I think about the ownership model, I think that's pretty unique. I think nowadays the way we do that is in these sort of agreement forms, right? The confidentiality and agreement forms that we're required to accept or agree to, or accepting cookies, for example. But it's interesting you brought that up because I definitely think there's a lack of education about the significance of these agreements. And also there's almost sort of like a dark pattern, a UX pattern in how these are shared, because sometimes you can't interact with the website or application at all unless you agree, right? So if it's something that you determine is integral to your use cases, then we just click agree and we don't even read through and see if there's an inclusion or clause about them sharing with other partners automatically as opposed to seeking our permission. So it'd be interesting to have like a model maybe that tells you like, hey, you're agreeing to this, but did you know that it's not going to just keep it within itself? It's going to share it with XX companies that we've noticed similar clauses or agreements with. And maybe that can make us take a step back and think more before clicking agreement to these terms. Yeah, no one reads those forms. I admit I do not read those forms. Yeah, no. Imari had asked, who are some of the researchers you turn to for inspiration in these social use? Oh, that's a great question. Does anyone have any researchers or scientific community participants that you turn to? Maybe your previous PIs or mentors? I can share some of mine. One of my mentors, Joyce D. Williams, she's a lead research scientist at the National Geospatial Intelligence Agency, and she lives and breathes AI for social good. So she's really particularly passionate about AI in education and ensuring that the next generation sort of is fully represented in how the differences in how students learn and how students are accounted for, the diversity of the different types of teaching and understanding learning styles. She's focused on creating tools now and working with organizations to build out solutions to these questions. So those are one of the people that when I think about AI for impact and social good, I definitely turn to her. Oh, nice. Okay, so 80,000 hours has a priority theme of research on AI safety. Nice. That's very important. Yeah, I think, there's the big field of like cybersecurity, but I definitely think there might have been sort of a disconnect with cybersecurity somehow incorporating AI security or machine learning security and the likes. So I think it might be time to merge those, not just sort of mitigating in the cyberspace, but even just in the development space. How do we ensure security of our models and of the users of the models too? All right. If no more questions, thank you all for sharing. Here's how you can stay in touch with me on LinkedIn. You can just type my first last name, Fabian Reese, and I should pop up. I don't think anyone else has my name, so you should be able to find me, hopefully. GitHub, same thing, github.com/Fabian Reese, and email fabianreese@gmail.com. And I leave you with this quote by Albert Einstein. Imagination is more important than knowledge. So stay creative, and thank you all for attending.
Thank you so much, Favor. That was wonderful. This video will be available on the session page as well as on YouTube, so you can reference it whenever you like. And thank you everyone for attending, for your questions. And thanks again, Favor, for joining us and making this workshop happen. We appreciate it. All right.
Thank you all. Bye.
Thanks, everyone.